Hello, we are doing checkpoint 5.17. They want us to sketch the region R, where R goes from 1 to 2, and theta goes from minus pi over 2 to positive pi over 2. And then they want us to evaluate this double integral. This is over the region R, and our integrand is x dA. Okay, so first let's figure out what this region is going to look like. Let's just work with, let's say the angle was equal to 0, and we have an R value that goes from 1 to 2. So we'll have that sort of piece of strip. We're looking at a radial distance, and as we move theta from 0 to, let's go negative pi over 4 or pi over 2, and then we'll move this to negative pi over 2. We're going to drop down to a y value of -1 and -2. Likewise, we move that up to pi over 2 positive, and move this part up to pi over 2 positive. We're going to get this region, the R length that we are moving around the angle is going to give us this, it looks like half of a washer, the half that's going towards the positive x-axis. All right, so now let's work with this double integral. And now that we know the region, we'll call this region R. And then a double integral over R of x dA. This is most appropriate to use polar coordinates, so we will use polar coordinates. We have our limits already set up here, and we just need to change all the x's and y's into R cosine thetas and R sine theta. So there's no y, so let's just leave it at that. Now the dA is dr d theta, but remember that the transformation requires you to include an extra r that comes out. And then your r limits, dr is going to go from 1 to 2, and d theta is going to go from minus pi over 2 to positive pi over 2. Okay, so I do want to point out that this r dr d theta is the transformation that happens from the dA, and so the r is part of it. Okay, from here we'll also notice that we can factor things out. The cosine theta is constant with respect to r. Basically, if you're not adding, subtracting, if you're not putting things into functions, if you're just multiplying things, then you can break them apart. And what I mean by that is that you can really do two separate single integrals. The single integral where we have a cosine theta d theta, theta goes from pi over 2, negative pi over 2 to pi over 2. And then that would have been taken out of the inner integral, which is going to be the integral from 1 to 2 of R squared dr. Okay, so the R squared comes from this R and this R, dr, and theta is constant, so, and it's a factor that we can multiply out, we can bring that out, and so this is what we have now. All right, now let's integrate them separately. So these integrals are they're probably just as easy as the iterated integrals, except you're not dealing with an integral within an integral. You just do two separate integrals. The antiderivative of cosine is positive sine theta, and we're going to put negative pi over 2 and pi over 2. So if we put a pi over 2 in first, that's going to be a positive 1, minus if we put a negative pi over 2, that's going to be a negative 1. So we're going to get a value of 2 here. We get 2 for the cosine integral. Now the antiderivative of R squared is 1/3 R cubed. We're evaluating this where R goes from 1 to 2, And then we have 1/3. If we put R, 2 in for R, we're going to get 8 minus, and if we put 1 in for R, we're going to get 1. So that looks like it's going to be 7/3. Okay. So now that we have these two integrals, the result's just 2 times 7/3, which is going to give us 14/3. And that's it. Okay, I hope that helps.